Hi everyone! Sorry I can't be here in person today, but hopefully this quick video through the notes helps you all try to start accomplishing some of this homework. We will go over questions from homework 5 in our next class, so kind of hang on to those. I did get the answers posted for both homework 4 and homework 5, so if you want to go back and check over those answers now, you can. Sorry it took me so long to get those up, but they are up now. Okay, so last week we started learning about inscribed angles, and now we're going to talk about some other types of angles and circles. The first thing to kind of notice, and hopefully this will help, and you'll get used to this as we talk about them more, but the first types of angles that we've learned about have been angles inside or on circles. So we talked about central angles, right? Central angles, we said the vertex is at the center of the circle, and then the sides are to radii of the circle, and that makes an angle which is a central angle, right? We had angle BAC is a central angle. Then we moved on and we started talking about inscribed angles last week. That's where our vertex is on the circle, and then the two sides of the angle are chords of the circle. So here, angle 1 is an inscribed angle. Right? We also have some other angles we can make inside circles, and that's when we take two chords and just make them cross at any point inside the circle. And this one is labeled angle 1 here, but we've made kind of 4 angles that go around the circle there, or inside the circle with those two chords. So that can also be a way to make angles in circles. Okay, so those type of angles, to find the measure of those angles, if I want to find the measure of an angle inside a circle that's formed by two chords, we've got a theorem here, the measure of that angle is equal to half the sum of the measures of the intercepted arcs. Okay, so if I'm looking at angle 1 right here, right, that's created by, use two colors here, I've got this segment AD, and then I also have segment CB, right? So one of the arcs intercepted would be AC, and the other arc intercepted is BD, if I'm looking at angle 1, right? So if I wanted to find the measure of angle 1, I'm going to do half the sum of the measures of the intercepted arcs. So half is 1/2, and then the sum of those arcs, so I do the sum of the measure of arc AC plus the measure of arc BD, right? Because those are the two that are intercepted. Now, if I had, let me show you another way here. If I was maybe looking at this angle, right? Let's call that angle 2. So now I'm still kind of using the same chords, but now I'm looking at them kind of from the other side. So CB and AD going this way. Now I'm going to look at these two intercepted arcs. So if I want the measure of angle 2, then I'm going to do half the sum of its measure, or the measures of the intercepted arcs, which would be the measure of arc CD plus the measure of arc AB, right? And then notice that angle 1 and this angle over here are vertical angles, so they would be congruent. Angle 2 and the angle over here, those would be congruent because they're vertical angles, right? And you can kind of see that too because they have the same intercepted arcs, right? Okay, but there's your formulas. If you've got an angle formed by two chords in a circle, then we just add together its two intercepted arcs and then take half of that. Okay, and we'll do a couple examples with that, so you'll see kind of how that works. Okay, then we've also got a couple cases where we have angles outside of circles, and you can see the 3 cases here. The first case is where I take two secants. Oops, if I can spell it right. There we go. Two secants, right? And I make them intersect outside the circle. Secant, remember, is a segment, array, or a line that crosses the circle in 2 points, but it extends outside the circle. So it's not just a chord, it's a secant because it goes over here outside the circle. Okay, so that's one case that we can create an angle outside the circle. So that creates this little angle 1 here. I can also use two tangents. So if I take two tangents and I make them intersect outside the circle, that also creates an angle there, right? Now we already know if I take two tangents and intersect them out in one point, that makes those two little segments congruent. But we're also going to have something about this type of angle when we create that angle out there. And then the last type is if I take one secant and one tangent. Right, so one of each. So now up here I've got a secant, and down here I've got a tangent. If I make those intersect in an angle, that creates, or I'm sorry, intersect in a point, then that creates an angle outside the circle. Okay, so 3 different ways that we can make an angle outside of the circle. For this one, it is very similar to our theorem up here where we add the two arcs together and then take half of it, except this time, since they are outside the circle, the measure of those is half the difference of the measures of the intercepted arcs. Okay? All right, so let's do some highlighting here so we can see where our arcs are. Okay, so if I'm looking at angle 1, let's start with that one. So the measure of angle 1, I'm going to look at its two intercepted arcs. So remember, your angle is created by these two secants, right? So the two intercepted arcs, well, one of them is here, and the other one is here, right? So I'm going to take half, just like before, and then I'm going to take arc AC minus, oops, I forgot my measure, sorry. The measure of arc AC minus the measure of arc BD. Now you do want to be careful on the order here. You want to do the bigger arc minus the smaller arc, okay? The second one with two tangents, it's the same thing. Let's see if we can do this one in a different color so you can see it better. Use green. Okay, so I've got my two tangents over here, right? So now for these two intercepted arcs, I'm going to look at the big one out here and then the small one here. Now this one's technically almost the whole circle, right? But they're meeting at those points there. Okay, so for the measure, I should have made this smaller, of angle 2, I'm going to do 1/2 the measure of arc. Now with this one being a major arc, I got to use 3 points. So B, D, C minus the measure of arc BC. So big arc minus the small arc. And then our last one, oops, different color here. We've got one secant and one tangent, but again, same thing. Here's our secant, here's our tangent. So again, I'm going to look at this arc, the bigger one, and then the smaller one on the inside, right? So for the measure of angle 3, I would do 1/2 the measure of arc AC minus the measure of arc BC. Okay, so you're looking for the two arcs that the angle intercepts. Take the bigger one minus the smaller one, and then take 1/2 of that. Okay, the big thing to remember too, to help you remember, is with angles inside circles, that's up here, right? If you're doing these, we're going to add the arcs together and then take 1/2. If they're angles outside the circle, like these guys, then you're going to subtract and take 1/2. Okay, all right, let's try some examples so you guys can see how these work. All right, so this one I want to find the measure of arc CB. So I'm looking for the measure of this arc over here, right? Now I already have one of my angles. This angle here and this angle here are vertical angles, so those are congruent. So I can say that this one is also 75 degrees, right? Okay, so then I know the measure of my angle. What I don't know is the measure of this arc. But since I'm looking at an angle that's made inside the circle by two chords, I can use that formula where the measure of my angle is equal to 1/2 the measure of the two arcs added together because this is an angle inside, right? So the other arc I'm going to look at is that guy over there, which we know. So that helps us, right? So I'm going to do the measure of arc AD plus the measure of arc CB. And then I'm going to plug in the stuff I know. So the measure of the angle, I know, right? That's 75 degrees. And then I'm going to do half. The measure of arc AD, I know. That's 100 degrees. Plus, I don't know the measure of CB. That's what I'm looking for. So I'm going to call that X. Okay, see if you can see where all the parts came from. The angle is equal to half the sum of the measure of the two arcs. I know one of the arcs. I don't know the other, but I do know the angle, right? So we can plug all those things in. Then it's just solving that equation. I'm going to multiply both sides by 2 to get rid of the 1/2. So that'd make this 150 equals just 100 plus X. And then subtract the 100. So our X would equal 50. So the measure of arc CB is 50 degrees. Okay. All right, let's try the next one. Okay, this time, again, I noticed right away, this is an angle outside the circle. Since it's outside, that means I'm going to be subtracting, right? But I've got an angle formed by, this time, a secant and a tangent. We are looking for the measure of the angle this time. So if I want the measure of angle 1, that's going to be equal to 1/2. And then I want the big arc minus the small arc. So in this case, my big arc is AC minus my small arc, which is BC, right? Okay, I'm looking for the measure of angle 1. So I'm going to call that part X or Y or whatever you want to call it. Or you can just leave it measure of angle 1. 1/2. The measure of arc AC, that's this one over here. We know that part. That's 160 degrees. Minus, well, BC I don't have a measure for, but I do know AB up here, right, is 120. BC would finish off the circle. So if I add together my 160 plus 120, that gives me 280. And then if I do 360 minus my 280, that gets us 80. So that means arc BC over here is 80 degrees. So I'm going to plug in 80 for arc BC. Right? So if I want the measure of angle 1, I do the big arc minus the small arc, take half of that. So we get 1/2. 160 minus 80 is 80. So X would equal 40. So the measure of angle 1 is 40 degrees. Okay, figure out if it's outside or inside. Write down your formula. Plug in as much as you can. If you got to find other pieces to be able to plug in what you need, then you can do that. Okay. All right, our next two circles to come up. Okay, so this one tells us that the measure of arc BDC, so BDC would be the major arc that goes around there. So that's 260 degrees. We want to find the measure of angle 1. Well, if that one is 260, we're left with our other arc in here. 360 minus 260 is 100 degrees, right? Would be that arc. And then we're looking for the measure of angle 1. That's outside the circle. It's an outside angle. So to find the measure of angle 1, I would do 1/2 the measure of the big arc. So my 260 minus the measure of the small arc, which is 100. So then our measure of angle 1 is 1/2. 260 minus 100 is 160. And then half of 160 is 80 degrees. So the measure of angle 1 is 80. Okay, hopefully it's starting to make sense. If you need to pause and ask a friend to make sure you understand, you can do that. Okay, our next one, this time, okay, so notice, same picture. That comes up, there we go. Same picture here, right? Last time we were given one of the arcs. This time we're just given the measure of the angle. So the measure of our angle 1 is 58 degrees. We're using that same formula, right? The measure of angle 1 would equal 1/2 the big arc, the measure of BDC, minus the measure of BC, that arc, right? Problem is this time we don't know either arc. But notice when we use two tangents, just like we did on the first one, the two arcs will add up to 360 degrees, right? So if I make this arc x, then my other arc would be 360 minus x, right? Because those two have to add up to 360, or you could do it the other way around. It doesn't matter which arc you make x. Okay, so then my measure of angle 1 is 58 degrees. I used x for the big arc. And then I'm going to do, and I'll be careful on your signs here, minus 360 minus x. I'm putting that in parentheses because I got to subtract the whole thing. So that'd give me 58 degrees equals 1/2. That'd be x minus 360 plus x, right? So then 58 degrees, 1/2, we get 2x minus 360. And then you could either, let's see, I'm going to multiply both sides by 2 instead of distributing the 1/2. That sounds easier. So 58 times 2, that's 116. And then 2x minus 360. I'll add over my 360, which gets me 476 equals 2x. All right. And then our 476 divided by 2 would mean that's 238 equals x. Okay, now be careful here. We found x, right? We want to know the measure of BC. I probably should have done this the other way if I was thinking better, right? But when I found x, that's the arc BDC. I actually want the measure of arc BC. So then to find BC, I'm going to do 360 minus 238. And that's 122. So the measure of arc BC would be 122 degrees. Okay. Had I slowed down a little bit and thought about that, maybe in hindsight, I should have made BCX and BDC 360 minus x, and then I wouldn't have had to do the extra step. But either way will work there. Okay, same formula, plug in the stuff you know, solve for what's missing, and then make sure you're actually answering the question. Okay, our last two. Okay, on this one, notice we're back to, now we've got an angle inside the circle. So we're going back to addition, right? We want to find the measure of arc CB. This time we've kind of got all the parts, right? Here's our angle. So I'm going to look at the other intercepted arc over here. There's our two intercepted arc. It's just some algebra in this problem this time. So if I want to make an equation here, remember the measure of our angle would equal 1/2 the measure of arc AD plus the measure of arc CB. This time it doesn't matter what order I put those in because we're adding. Okay, so the measure of our angle is 94 degrees. Arc AD is 5x plus 6, and arc CB is 2x. I just plugged in the stuff that I knew. I'm going to multiply both sides by 2, so I don't have to deal with the 1/2. So that's 188 equals 5x plus 6 plus 2x. That makes 7x plus 6. And then if we subtract 6, we get 182. And then if we divide by 7, we get x equals 26. Okay, we solve for x. We wanted here the measure, oops, didn't mean to scribble that. Didn't change to my highlighter. Come on, computer, there we go. I want the measure of arc CB, right? So to get CB, I'm gonna do 2 times 26 because CB is 2 times x. 26 times 2 gives us 52 degrees for the measure of arc CB. Okay. All right, then our next one, we're looking for the measure of arc SY, or we have that, sorry. We have the measure of arc DC. We want the measure of arc AB. Okay, so we've got a couple circles on this one, right? We'll kind of label the stuff that we can. So SY is here. That's 112 degrees. DC is our arc out here. Oops, I'm going to do that in a different color. Come on, OneNote. There it goes. Okay, DC is out here. That's 87 degrees, right? And then we're trying to find the measure of arc AB, right? Okay, so what I notice here is we've got an angle here, right? And if I look at the small circle, so I'm actually going to draw this over here separately so it's easier to see. So if I look here, this is X, right? And then we've got these two chords. This is S, this is Y. And that's 112 degrees. Now notice that's an inscribed angle. That's what we learned about last week, right? So the measure of this angle is just going to be half of our arc, right? The measure of an inscribed angle is half the measure of the arc. So the measure of angle SXY would be 112 divided by 2, which is 56 degrees, right? So in here, this angle is 56 degrees. Okay, now that I have that angle, notice that if I extend these chords, then I get my green and my blue intercepted arcs. That's an angle inside the circle, so now I can use my measure of an angle, or the inside angle, would be 1/2 the measure of the sum of the two intercepted arcs. So that would be arc CD plus the measure of arc AB. Okay, so our angle we know, that's 56 degrees. And that's half. The measure of arc CD is 87. And then the measure of arc AB, that's the one we're looking for. So that's X. Again, I'll multiply both sides by 2. So 112 equals 87 plus, oops, not 8x. Whoops, rewrite that. Come on, OneNote. Slowly. It won't erase for me, huh? Okay, oh, there it goes. 87 plus x. And then that means if I subtract 87 from both sides, x would equal 25. And x, we said, was our arc AB, right? So the measure of arc AB is 25 degrees. Okay, so that's kind of putting together our inscribed angle stuff that we talked about last week with this new stuff. So you've got a couple things you can see in that picture. Like I always say, like just start marking up your picture and find something, even if it's not what you're looking for. If you just start trying to find some measurement in your circle, then that might help you find something else. And that might eventually get you to what you are trying to find, right? So just start trying to do something. Okay, then our last section down here Brings up the rest of our picture. We got a big picture where we're trying to find all of our angles. And you're going to have one kind of like this on your homework. Okay, so we'll start kind of using all the things we've talked about with our angles, right? Think central angles, think about inscribed angles, and we can also think about all of these new ones that we've seen today where we can add and subtract the intercepted arcs, okay? You don't have to do these in exactly the order that they're given to you. That's totally up to you, okay? Okay, so if you want to just start kind of picking pieces apart, the one that jumps out to me right away is angle 6. That's an outside angle. That's one of the ones that we learned today. And the reason that one jumps out at me is that I know it's 2 intercepted arcs. So I see this guy over here, which is 100 degrees, and then also this one here, which is 30 degrees. And if this is an outside angle, then that means I want half the measure of the 2 arcs subtracted, right? So for angle 6, I'm going to do 1/2 of 100 minus 30, which is half of 70, right? Which is 35. I can do that math. So half of 70 is 35. So angle 6 is 35 degrees. Okay. That one jumped out at me because I could tell I knew those 2 arcs. So I just noticed that one, so that's the one I did first. If yours is different, that's totally fine. Okay. Let's see, what else? We also have, okay, I also notice angle 3 over here, right? With angle 3, I'm going to look at, that's an inscribed angle because our vertex is on the circle, and its intercepted arc would be this whole thing, right? Now with an inscribed angle, I just do half of the intercepted arc. Well, that intercepted arc would be 30 plus the 25, which is 55. So the measure of angle 3 would be half of 55. Right? So angle 3 would be 27.5. I'm going to start kind of writing some of these on here too. Got that one. This one's 35. Okay. All right. There's another one we know. Oh, let's see. What else? Angle 7. Well, let's look at angle. I see. Okay. Let me go backwards. I'm going to look at angle 1 and 2 here. And the reason I want to look at 1 and 2 is here's the center of my circle, right? So 1 and 2 have to add up to 180 degrees because they are along our diameter there. And also these are central angles, right? So angle 2 goes with that 100. Since it's a central angle, central angles are exactly the same as their intercepted arc. So angle 2 is going to be 100 degrees. And then if 1 and 2 have to add up to 180, then that means that angle 1, along with its intercepted arc, is 80 degrees. Okay, so those two have to make a diameter or a semicircle, right? And you could have seen the arcs before you caught those angles. Some people will catch that first. Okay, so then what else can we get? Let's see. That means over here, angle 7, we can look at its intercepted arc, right? Now this one is one where we've got a chord and then a tangent, but remember the rule is still there. The measure of that angle is half of its intercepted arc. So if I'm going from there to there, that's actually 180 degrees. So angle 7 would be 90 degrees. It's half of that intercepted arc. The eraser's being slow here. I'm just trying to erase the extra lines, but it's not erasing. Okay. All right, so then if I know that that is 180, oops, nope, sorry, not 180. I wrote the wrong number. That should be 90. There we go. That's 90 degrees. And then over here with 3 and 8, I know that that whole thing has to make a straight angle, right? So 8 plus 3, angle 8 and angle 3 have to add up to 90 since angle 7 is 90. So to get measure of angle 8, I can do 90 minus 27.5. And that gives us 62.5 for the measure of angle 8. Okay. You could have also taken all of these arc measures, added them together, and subtracted from 360 to get the arc over here, and then cut that in half to get your 62.5. Or if you want to go ahead and get that number, so that would have been 125 degrees over here. And then I could have taken half of that to get my 62.5. There's a couple ways you could have got that one. Okay, what do we got left? We know this one over here is 80. This one's 100. Mark those on there. 4 and 5 are left, right? Okay, now those, I'm looking at two chords that intersect. So I'm going to add together their intercepted arcs and take half. So if I look at 4, well, it's got this arc here that is 80. And then it's got this arc here that is maybe I should draw those on there. Let's do a highlighter here so we don't miss anything. Come on, highlighter. Maybe. Wait for OneNote. There we go. Okay, so 4 intercepts. We've got this arc here. And then our other one goes from here all the way to there, right? So that other arc is actually the 125 plus the 30. Okay, so for the measure of angle 4, I'm going to do 1/2 of 125 plus 80. If I add those two together, 125 plus 80 gives us 205, and then half of that would make 102.5, angle 4. Now I could go through the same process to get angle 5, but anytime I've got these two, those are supplementary, right? So I could just do 180 minus 102.5, and that gives us 77.5. Okay, there's a lot going on in that picture. Hopefully you were able to follow how I did each one. Know that you could have done them in a completely different order and used different pieces to find other things, but it also kind of shows you that you can have central angles, inscribed angles, and now these other types of angles all in one circle and how they all kind of work together. Like I said, just start trying to find something to get started. And then we'll take some extra time in our next class to kind of go through questions on this homework and go back through the notes if you guys had any questions on these. I know I kind of went through this faster than we probably normally would in class, and you weren't able to ask questions as we went. So try your best with the homework, but try to attempt to do some of it. It is book work again. The pages are in OneNote, and I think it's a pretty simple numbering. It's just 1 through 21 and trying all of those. The very first part is like that last one we just did. It's really similar. You've just got one big picture here, and then you're trying to find so each number in the circle is like number 1, number 2, number 3. You can just number those on your paper like that. I suggest redrawing that picture on your homework so you can actually mark it up. Otherwise, you'll get confused on what's what. So try your best to kind of copy that picture onto your homework and label stuff, maybe even draw it bigger than what you see it here in OneNote. Okay, I will see you guys next class. Like I said, we'll go over questions then, but try something. Help each other out if you need anything. See you guys soon.